The universe is formed of an incalculable number of stars, contained within billions of galaxies. This enormous amount of matter and energy originated a little less than 15 billion years ago, when a powerful explosion occurred, the Big Bang. This primordial explosion released an immeasurable amount of energy, which very rapidly was transformed into grains of matter. The matter gradually became organized as the universe cooled. After 300,000 years, the first hydrogen and helium atoms appeared. It took another billion years for the atoms to group together and form clouds of gas, stars, and galaxies. 9 billion years later, billions of galaxies existed in the universe. Within one of these galaxies, our solar system was born. Our solar system is located in a galaxy called the Milky Way. Seen from Earth, the Milky Way looks like a narrow strip of milky white, which is where it gets its evocative name. If we were to view it from outside, however, the Milky Way would look completely different. Seen in profile, it has a central bulb, which contains tens of billions of stars, around which spreads a thin disk 100,000 light-years in diameter. This disk is formed of long trails of stars coiled into a spiral and called spiral arms. Each arm has a different name. For instance, one is called the Centaur arm and another is called the Swan arm. Our solar system is in the Orion arm, 28,000 light-years from the center of the Milky Way. Massive stars have a spectacular but relatively short life. Like all stars, they are born in an immense cloud of hydrogen and helium. Slowly, the hydrogen is converted into helium. It is this transformation that makes the star shine. But unlike small stars, a massive star consumes its hydrogen very quickly, so that it remains stable for only about 500 million years. After this mature stage, the star begins to swell considerably. It becomes a supergiant, a star 500 times larger than the Sun and 10,000 times brighter. Within the supergiant, the hydrogen is converted into heavier and heavier elements, up to iron. At this stage, the nuclear reaction stops and the star is deprived of energy. In a fraction of a second, the matter in the outside layers is attracted to the very dense core of the star, against which it bounces. The star is destroyed in an extremely violent explosion. It becomes a supernova, which ejects into space the chemical elements generated by the star. For several hours, the supernova is the brightest object in its entire galaxy. Then the core compacts to the point where it becomes a neutron star, a celestial body just 10 kilometers in diameter, but containing more matter than the Sun. Black holes are among the most intriguing objects in the universe, since they are invisible. A black hole is formed when a massive star dies. The core of the star collapses on itself, and its enormous mass is concentrated in an infinitely small space called a singularity. The singularity is so dense that it disturbs the surrounding portion of the universe. The universe can be thought of as a gigantic mesh. The stars sit on the mesh, thus distorting it. The denser the celestial body, the greater the distortion it causes. In the case of an infinitely dense black hole, the distortion is infinite. This kind of black hole can be thought of as a bottomless well. Objects that pass by at a distance are not greatly affected, but those that pass by quite close are pulled toward the bottom of the well and can never escape. Light rays that pass by close to a singularity meet the same fate. They become trapped. A black hole emits no light at all. It is invisible. However, when matter, such as the gas envelope of a star, is drawn into a black hole, it does not fall directly into the well. It starts by spiraling at a very high speed and heating up. A disk of hot, very bright matter, the accretion disk, forms around the well, signaling the presence of the black hole. This is how astronomers have been able to detect black holes in the center of a great number of galaxies. A comet is a small, icy celestial body whose spectacular tail can be seen from Earth. A comet's luminous plume is visible only when it approaches the Sun. The comet's core, composed of dust and ice, heats up and begins to melt. The matter surrounding the core is vaporized and forms a very bright halo of gases, and an enormous cloud of hydrogen envelops the head of the comet. Tiny particles expelled from the core make up the dust tail of the comet, which is several million kilometers long. An even longer ionic tail is formed of gases that are ionized, that is, electrically charged, through interaction with the solar wind. Most comets orbit around the Sun in very eccentric orbits that take them out to the edges of the solar system, beyond Pluto's orbit. They therefore appear in the sky only once a century or once a millennium. Others, like Halley's Comet, do not go beyond Pluto's orbit. They therefore pass close to the Sun more often, every 76 years in the case of Halley's Comet, whose next passage is expected in 2061. The Moon is the second brightest celestial body in the sky after the Sun. It is also the closest to Earth, only 384,000 kilometers away, a distance equivalent to 30 times Earth's diameter. Earth's only natural satellite, the Moon makes a complete revolution of the planet every 28 days approximately, always presenting the same face. The internal structure of the Moon is similar to that of Earth. At the center is a ferrous core, probably very small, covered with a thick rocky mantle and a thin crust. But unlike Earth, the Moon has no geological activity. Its crust is composed of very old rocks dating back to the birth of the solar system. It is pitted with craters, most of which are due to the impact of meteorites over billions of years. The Moon also has vast plains of solidified lava, which are called seas. For example, the Sea of Tranquility. They form dark regions visible from Earth. Its mountainous regions, called highlands, appear lighter. This landscape has remained almost unchanged for billions of years. The Moon can thus be considered a fossil celestial body, offering clues as to the infancy of the solar system. In order to get as close as possible to the object of their studies, space, astronomers place their observatories on mountaintops. The Mount Palomar Observatory in California was one of the first very powerful astronomical observatories. Brought into service in 1948, Mount Palomar has been the site of important astronomical discoveries. Its gigantic dome covers a mirror 5 meters in diameter and weighing more than 12 metric tons. A key factor in the performance of a telescope is the diameter of its mirror. Since it is difficult to make mirrors that are both large and strong, the latest generation of observatories uses a combination of many smaller mirrors. The Keck telescope in Hawaii has 2 domes, each covering 36 hexagonal mirrors, 90 centimeters per side. Together, these small mirrors reproduce the performance of a single 10-meter mirror. The gigantic telescope of the European Southern Observatory is located atop Mount Paranal in Chile. Called the Very Large Telescope, it combines 4 mirrors, each 8.2 meters in diameter, for a precision equivalent to that of a mirror 120 meters in diameter. Because of these instruments, astronomers can obtain valuable images of our universe without leaving Earth. Since 1990, the Hubble Space Telescope has been orbiting Earth at more than 600 kilometers altitude. This astronomical observatory in space is not subject to the distortions caused by Earth's atmosphere. The Hubble Space Telescope is a bus-sized satellite powered by huge solar panels. It is equipped with a mirror, 2.5 meters in diameter, which senses cosmic rays, from ultraviolet to infrared. These rays are analyzed by a number of onboard instruments, including the Wide-Field Planetary Camera, which has produced some of the most spectacular images from the Hubble Space Telescope. In its first 10 years of service, the Hubble Space Telescope has provided more than 330,000 pictures of over 25,000 celestial objects. These images are exceptionally clear, in part because the telescope can be pointed in one direction of the universe in an extremely accurate and stable manner. From now until 2010, when its mission is scheduled to end, it should supply even more data, adding greatly to our knowledge concerning the size and structure of the universe. Since the launch of the first artificial satellite, Sputnik, in 1957, thousands of spacecraft have been placed in orbit around Earth. Most are satellites. Some study developments on our planet and in its atmosphere. Others are telecommunications relays. Many space telescopes, such as the Hubble, are also in Earth's orbit at an altitude of 600 kilometers. The space around Earth is permanently inhabited. At the International Space Station, under construction 380 kilometers above our heads, small groups of astronauts rotate in and out of service every 4 to 6 months. Crews and assembly modules for the station are transported by the Russian Soyuz vessels and the American fleet of space shuttles. The shuttle is the only space vehicle that can be reused, except for its huge external fuel tank. In service since 1981, the fleet of space shuttles has completed more than 100 missions. The hold of the space shuttle can accommodate almost 20 metric tons of equipment, and its remote control arm enables it to perform all sorts of operations in space. The most delicate operations are performed by astronauts in spacesuits, as was the case for the repairs to the Hubble Space Telescope. Mars is the most thoroughly studied planet in the solar system. Since the 1960s, 40 space probes have been launched in its direction. In 1965, the Mariner 4 probe sent back the first images of the desert-like surface of the red planet. A few years later, Mariner 9 observed impressive geological formations, such as Olympus Mons, which is 27 kilometers altitude. Traces of erosion indicate that there was once liquid water on Mars. In 1976, the Viking 1 and Viking 2 probes landed on Mars. For 6 years, they transmitted fascinating panoramic views of the red and rocky soil of Mars back to Earth. 20 years passed before a third probe landed on Mars. In 1997, the Pathfinder probe landed a miniature vehicle named Sojourner on the planet. The probes operated for 3 months and sent back large amounts of data on the Martian environment. At the same time, the Mars Global Surveyor probe was placed in orbit to take an overall portrait of the planet. It supplied hundreds of thousands of bits of information, especially on climatic variations. In 2001, the Mars Odyssey probe made an important discovery. Its analyses suggested the presence of traces of underground water. The Mars Express probe, placed in orbit in 2004, detected the presence of frozen water at the Martian poles. At the same time, the 2 all-terrain vehicles, Spirit and Opportunity, were landed on Mars. Capable of traveling hundreds of meters, they are transmitting much information on the Martian soil.